Alright, question 2 is the circuit question. 2.1, calculate the reading on voltmeter V2. There it is, it's a voltmeter over the 6 ohm resistor. So we're applying Ohm's law. The voltage in the 6 ohm resistor is equal to IR. The current flowing through the 6 ohm resistor is determined by ammeter A2, and we're told that's 1 ampere. So the current flowing through the 6 ohm resistor is 1 ampere. The resistance is obviously 6, so 1 times 6 gives us 6 volts. So the voltage over the 6 ohm resistor measured by V2 is 6 volts. 2.2, calculate the reading on ammeter A1. There it is, and that's measuring the total current of the circuit as well as the current that flows through the 4 ohm resistor. So we're going to apply Ohm's law to the 4 ohm resistor, and I, the current in the 4 ohm resistor, is equal to V over R. Now the total external voltage is 18 volts, that's shown by voltmeter V1. We've just determined that 6 volts is used over the parallel combination, which means that over the 4 ohm resistor we must have 18 minus 6 volts. So let's put that in for V. The resistance of that resistor is 4 ohms. So that gives us 12 over 4, which is 3 amperes. So the total current flowing through the ammeter A1 as well as the 4 ohm resistor is 3 amperes. Right, 2.3, calculate the resistance of R. What do we know? We know that the total current is 3 amperes. We've just worked that out. We know that the current splits in the parallel branch, and we can see that 1 ampere goes through the 6 ohm resistor, which means that 2 amperes must go through resistor R. And so the 3 ampere total splits 1 ampere through the 6 ohm resistor, 2 amperes through resistor R. We also know that the voltage over the 6 ohm resistor is 6 volt. We calculated that in 2.1. And because they're in parallel, the voltage over R must also be 6 volts. So that gives us enough information now. We can apply Ohm's law to the to resistor R. V is 6, the current is 2, so 6 over 2 gives us 3 ohms. Alright, 2.4. We're told that the EMF of the battery is 20 volts and asked to calculate the internal resistance. I'm going to show you 2 ways. The first way is much longer and the second way is much quicker. What do we know? We know the total current is 3 amperes. We know that resistor R now is a 3 ohm resistor. So we can start by considering the combined resistance of that part of the circuit, which is the parallel part. So 1 over R parallel is 1 over 6, that's a 6 ohm resistor, plus 1 over 3, that's a 3 ohm resistor. And that gives us 3 over 6, and so R parallel is 6 over 3, or 2 ohms. The total resistance then is the 2 ohms from the parallel branch, plus the 4 ohm resistor, which is in series, which gives us a total of 6 ohms. So total resistance of the external circuit is 6 ohms. If we now apply our EMF formula, we know that EMF is 20, we know the total current is 3, total resistance is 6, and that allows us to solve for internal resistance little r as 2/3 of an ohm. A much quicker way is to apply Ohm's law to the battery itself and to say that V internal, the internal voltage, or what we would call the lost volts, is equal to I, the current flowing through the battery, times by R, the resistance of the battery, or the internal resistance. Internal resistance, or lost volts, is simply EMF minus V external, so that's 20 minus 18. You can see 2 volts is lost in the battery. Current is 3 amperes, we've worked out the total current, times little r, which again gives us internal resistance is 2/3 of an ohm.